how many terms of arithmetic progression 3, 10, 17 and so on will give a sum of 679. So what we have given here? We have given arithmetic progression. Let me write this 3, 10, 17 and so on. We have that the sum is equal 679 of these terms of arithmetic progression. And what we have to find? We have to find how many terms of arithmetic progression give us sum 679. So unknown is n. We have to find how many terms. So let me remind you formula for the sum of n terms of arithmetic progression is a1 plus an over 2 times number of terms of arithmetic progression. What we have here in this formula? We have sum. This is given. a1 is first term of our arithmetic progression. an, we don't have the last term, but we can find an from the formula of n term of arithmetic progression is a1 plus n minus 1 times d. D is the constant and is the number of terms. So we have given first term, second and third term of our arithmetic progression, so we can't find the d, the constant. This is the number which we add to the first term to have the second, and to second we add this constant number to form the third number. So the d, in other words, is common difference. To find the d, we have to choose two consecutive terms and subtract first one from the second, and we will have a d. So we can subtract from a to a1, for example, or from a3 a2. a2 is 10 and a1 is 3, so minus 3 is equal 7. We have d. d is equal 7. So now when we go to this formula, the sum of n terms of arithmetic progression, our unknown will be only n. Let's first copy our formula. Sn is equal a1 plus an. We have that an is a1 plus n minus 1 times d. So we can substitute an by this form. So this is a1 plus n minus 1 times d. And we copy over 2 times n. What next? We have given the sum is 679. We have a1, we have d, only unknown is n here. So let me substitute everything what we have given. Sn is 679 is equal a1 plus a1. So we have 2 times a1. We can write a1 is 3. First term plus n minus 1 and d we found this is 7 over 2 times n. So unknown is only n in this equation. So first, to reduce this fraction, I will multiply both sides of our equation by 2. Let me start to write from the beginning. So 2 times 679 is 1358, and this is equal to, and 2 we can reduce, so we have in our numerator 2 times 3 is 6 plus n minus 1 times 7, and everything we have to multiply, so I will take in brackets by n. So what next? I will change the sides and I will do multiplication. Every term in parentheses, brackets, we have to multiply by n. So 6, n times 6 will be 6n, plus we have n minus 1 times 7 will be times n. This is equal 1, 3, 5, 8. So now we will do multiplication. N minus 1, we have to multiply by 7n. So we have 6n plus 7n times n will be 7n squared. 7n times negative 1 will be negative 7n is equal 1, 3, 5, 8. Now I will combine the like terms and we have 7n squared. So we will have here quadratic equation. We will start to write this quadratic equation from the highest power. So 7n squared, 6n minus 7n is negative n, and I will move 1358 to the left, so it will be negative 1358 is equal 0. We have quadratic equation. To find the solution, we will use form that n1, 2 is equal. Let me remind you formula. When we have quadratic equation a x squared plus bx plus c, this is equal 0. So the solution we have 1, 2, negative b plus minus square root of b squared minus 4ac over 2a. We have two solutions when expression under square root is greater than 0. When is 0, we will have only 1. And when expression under square root is negative, we don't have real solution. In our example, a is equal 7, b is equal negative 1, coefficient before n is invisible 1, and c is negative 1, 3, 5, 8. So let me substitute to this formula. We have in our example n unknown. So this is negative, sign we copy, and b is negative, so in parentheses will be negative 1 plus minus, and we have square root of b squared, so this is negative 1 to second power minus 4 times 7 times negative 1, 3, 5, 8 over 2 times a, so times 7. So this is equal, negative and negative give me positive, so we have plus minus. And what we will have under square root, we will use calculator. We have negative 1 to second power, so will be square root of, open parenthesis, like I said, negative 1 to second power, so will be 1. And we have negative times negative, so will be positive, so will be plus 4 times 7 times 1, 3, 5, 8, close parenthesis, so this is equal, we have 195 over 2 times 7 is 14. So we have two solutions, and 1 is equal 1 plus 195 over 14, and 2 is equal 1 minus 195 over 14. So 1 minus 195, so will be negative 194 over 14. This is less than 0, and n is number of terms in our sequence, so cannot be negative. So this is not possible to n equals to this value. So we can cross this. We have n1 only, 1 plus 195, so it's 196 over 14, so this is equal 14. So the number of terms is 14. For n equals 14, we have that the sum of arithmetic progression will be 679. First 14 terms give us 679. This is my solution. N must be greater than 0.